So here, the distribution of current. So what is the law? What is the method we are applying it? I'm going to connect a cell. Let the current enter here. I. Now look at this particular branch here. So what is the branch resistance? It is R. And what is the branch resistance here? It is R. So just looking at branch resistance, you cannot divide equivalent current. You should also look at the further the junctions. Are the junctions similar? So what are the junctions? We have junctions 1 and 2. And the junctions 3 and 4. Are they similar junction? It's again, what do you mean by similar junction? Again, look at the junction 1. Look at the junction 1. It is connected to the other junction by resistor R, and here one resistor R. Similarly, here the junction 2 also a resistor R and this one. So therefore 1 and 2 are similar junction. So then what happen? You can really put the current what happen will branch equally. This will be. So again coming for this means then I'll go for equal current distribution. So here it will be I by 2, I by 2. Then let's write KVL V1 or VB plus I by 2 R minus V1 equals 0. Similarly, VB plus IR by 2 minus V2 equals 0. From these two equations, I'll get V1 equal to V2. So on what basis you are dividing equal current in both the branches? So what is the requirement here? That they must have same branch resistance and the junctions 1 and 2 should be similar. Then only you can divide equal current in these two. Then by chance, if you make it this 2R, then what when V1 is not equal to V2. If you make this 2R, then what happens? You cannot divide current in these two branches same. So though they're having same resistance, because the junction 2 is not similar to 1. Okay, there are some next we are going to work out some problems of finding out equivalent resistance here. So therefore now V1 equal V2. If a resistor connected across points which are at same potential, means V1 and V2, no current flows through resistor R. So this resistor R can be removed from the circuit because as there is no current through this, so there is a resistor X, I'll call it. There is a Y. So no current through X. Therefore, I can remove this, whether it's present or absent doesn't make any difference in the problem. So better let's remove it so that the problem will become very simple for us. Similarly, I'll go for further the current.
So that is minus IR by 2, sir.
VB minus IR. Yeah, fine. So next again further. So the current here will not branch. So the same current I by 2. This I by 2. Again writing loop equation.
Sir?
Again, wait. Let me finish off. In the end, you can commit. VB minus I by 2R minus I by 2R minus V3 equals 0. Similarly, VB minus I by 2R minus I by 2R minus V4 equal to 0. So V3 equal to V4. So again, the 3 and 4 are same potential. So the resistor Y, no current through Y. If there's no current through Y, then what we can do, we can remove that particular resistance. If you remove it, then the circuit will become simple series parallel.
Sir, we cannot write I by 2 because there is one more branch. They'll be equal, but not exactly half of the current coming in.
I'll make correction. I'll make correction. Now here's some what I wrote. I dash. So some. I'll do one thing. I'll call this as say some high. Okay, fine. This is some current here. What happened? These two branches are not similar. They just make some this one. The current I will enter. So I by two. This should be I dash because these two branch the rest are connected across branch AB, and these two are not similar. Whereas these two branches are similar. So therefore, equal currents I should divide. Okay, fine. There's a correction I'm making it here. Fine. No, there is no resistor there. If I remove that resistance, so it'll become some simple series parallel, no? So once if I remove that, the resistor, the circuit will appear a simple series parallel one. Can we solve this? This will be much easier, no? This was the point. So here, the current we assumed it, let it enter, and the same current has to leave from here. So what is the value of resistance? Everywhere let it be R. So this 2R here, this whole 5R. So the equivalent resistor, the equivalent network will be off like this. This is R. So this will be 5R. So show that current, the total current is entering I, that much of current should leave. So means now, sir, how do I identify that? How do I come to know that which resistor to remove? That procedure is what you have to follow here. How do I come to know that which particular resistor no current flows? A resistor which is connected across equipotential, a resistor which is connected across equipotential points, no current through it, and the resistor should be removed. So what are the some two important things which I'm going to follow here? If a resistor connected across equipotential points, no current through it, remove that resistor from the circuit. This is the one thing. Similarly, if 2 points in a circuit are at same potential, then make them as common point, redraw the circuit and simplify further. These are, I think, two situations which we are going to come across. You have approximately around more than 100 numericals are there. All that 100 numericals just revolve around the same basic idea. Revolve around the same basic idea. This is, I'll just make that point. I'll put it here. If
Sir, 5R by 7 net
resistance, yeah, 5R by 7. If a resistor is connected across an equipotential point, no current flows through it, no current flows through it, and that resistor can be removed from circuit. Since there is no current, no, you can take it out from circuit, finish over that one. Similarly, if two equipotential points are available in circuit, there is no resistor connected. If two equipotentials are there, make those 2 points, two or more, not that one. If two or more equipotentials are there, make those 2 points as a common point and simplify the circuit.